This is example. Applicate ball of mass 0.3 moving with a velocity of 5 meters per second. So this is applicate ball A. Applicate ball what? A. Move of mass 0.3 moving with a velocity of 5 meters per second. Hits a stationary ball B, which is at rest. So after collision, B moves with 2 meters per second. Direction is 30 degrees to the initial direction of x-axis. Then A moves with the velocity of V, and then the direction is theta. So find the value of theta and find the value of V. So we draw the diagram again. We have this. This is A moving like this. Speed is 5 meters per second. Then here, the other moves up like this. Then A goes here. I think that's B. This is B goes there. The direction is what? 30 degrees. The velocity is 2 meters per second. So the horizontal what? The horizontal component of this velocity will be 2 cos over 30. Then we shall have this one here. This is V. Then this is A. This is 30. This is theta. So the horizontal component of V, the horizontal component will become V cos of theta. Then the vertical component here, we shall have this is 2 sine of 30. Then down here, we shall have V sine of what? Theta, but then negative because in that quadrant where the theta is, it is only cos, which is a positive, the rest are negative. So we shall now start horizontal motion. Horizontally, momentum for collision is M1 U1 equals M, here to be MA UA is equal to MA, okay, times VA, that is cos of what? Cos of theta plus MB, this is theta 1, MB VB, cos of theta 2. Supposing those are different what? Angles. So substitute, this is 0.3 times UN, our UN is initial velocity is 5, is equal to 0.3 times V of N is V cos of theta plus 0.4, that's 0.4 times 2 times cos of 30. So that means here we shall have 1.5 is equal to 0.3 V cos of theta, okay, plus, now what do you get there? There you can be able to get cos of 30 times 0.8, I think. Here we will have 0.969. So meaning that 0.3 V cos of theta will become 1.5 minus 0.69. I'll have 0.81. Can I divide by 0.3? Is it possible? It is not possible. Oh, sorry. 0.81 divided by 0.3. 2.7. So V, okay? V what? This one you can see it here. So we shall have V cos theta is equal to 2.7, equation 1. Then we go to vertical motion. Vertically, we shall now say that 0 is equal to MA V sine VA sine of theta 1. So this is negative, plus MB VB sine of theta 2. So we substitute That means MA comes this side. MA VA sine of theta 1 is equal to MB, the rest of B sine of the arm which B makes the horizontal. We substitute 0.3 sorry, times V sine of theta is equal to 0.4 times 0.4 times 2 times sine of 30. So 0.3 V sine theta would become what? 0.80 times sine of 30. The answer is 0.4. 0.4 divided by 0.3, what do you get? So our V sine theta will become 4 out of 3. This is equation what? Equation 2. How we divide? Equation 1 divided by equation 2. Equation 2 divided by equation 1. So we shall have V sine theta over equation 1 is V cos theta, giving us 4 over 3 times this is 0.7. So tan theta is equal to 4 over, this is 8.1. 8.1, is it 8.1? 3 times 0.3 times 2.7. 2.7 is 8.1. So theta will become tan inverse of that. So second shift, tan inverse of 4 divided by 0.8, 8.1. We shall have 26.3 degrees. Then we substitute in equation 1. Put in equation what? From 1, we shall say that our V is equal to 2.7 divided by cos of 26.3. So that's 2.7 divided by cos of 26.3. It gives us 3.0. V is equal to 3.01 meters per second. So that is example number 1. Go to number 2. So here we have this. Number 2, we are given a particle of mass m moving with a velocity of 10, collides with a stationary particle. So sketch diagram. We have a particle M. Moving with the velocity of 10 meters per second, collides with another particle. The particle B is here. This is B. So that they are saying that after collision, A moves with the velocity of U at an angle of 30. So A moves here. This is A. Velocity of U at an angle of 30. And then the other one moves this direction. B goes here at an angle of 90. This is 90. So this is 30. This will become what? This will become 60 degrees. This is X what? X direction. So that this is V. And we shall say that this is, along this one, this is V. Also value 60. Then this is V, that's U sine of 30. Then vertically, along the vertical motion, this way. Here we shall have a negative of this one here, which is V sine of 60. That's a negative. This is U sine of 30. Okay, so we can substitute, we can now solve. So we're saying that horizontally, so momentum for this one will be mass the mass is m times 10 is equal to, no matter for that one, it will be mass m u cos of 30. This is cos, not sine. Cos, horizontal. Cos of 30 plus m, because they have the same mass, identical mass, okay? So m times v cos of 30, 60. So m will cancel. 10 is equal to u. Now, cos of 60 is same as what? 0.88. Cos of 60, 0.88. So it is 0.866 u plus, what is cos of 60? It's the half of half, 0.5 u. So this is equation what? Equation 1. Then in practically, we shall have 0 equals negative mv sine of 30 plus, so the other one is mu sine of 30. So here we shall say m will cancel, so we shall have v sine of 60 is equal to u sine of 30. So sine of 60 is what? Sine of 60 gives us 0.8, okay, 6, then v is equal to, here sine 30, sine of 30 is a half, 0.5 u. So from here we can eliminate what? We can eliminate v, okay? Or can eliminate what? U. So therefore, make u the subject of the formula. So our u will become 0.866 divided by 0.5 times v. Then substitute in equation 1. This is equation what? Substitute in equation what? Equation 1. Equation 1 becomes what now? Equation 1 will become equation 1 now becomes equation 1. So it is 10 equals 0.866 u. But our u we have it already. Our u is times 0.866 over 0.5. That is it. Then plus 0.5 u. So when you add, we'll get 0.866 times 0.866 divided by 0.5, then plus 0.5. So then our v will not become 10 divided by the answer. Our v will not become 5 meters per second. Then therefore, our u will not become 0.866 divided by 0.5 times 5, which we shall have 8.66 meters per second. Then what else? Determine whether the collision was elastic or not. So how do you do such? Now, first we shall now say kinetic energy before is a half mu squared, which is a half times mass is mu times 10 squared, which gives us 50 mu joules, okay? Then we go to the kinetic energy after collision, okay? Kinetic energy after what? After collision. So shall go and say kinetic energy after will become a half times m times, for this one it is 5 squared plus a half times m times 8.666 squared. What do you get? So this is 25. So 8.666 squared. Then plus 25 plus 25 Divided by 2. So this becomes 49. So this is 49.997, which is equal m joules. Since kinetic energy before is equal to kinetic energy after collision, then the collision was elastic. Then collision was elastic. So we can go ahead and look at the exercise, not so? I put some numbers for the exercise. So we have one number, the exercise here, 2 particles of masses 2.5 and 3 moving at speeds or velocities of that and this respectively in the direction to the right angle. So that means that if one is moving like this, another is moving like this. So suppose they collide around here. Suppose they collide around here. So that means that after collision, you don't expect them to come this way, this down, or there. So they will go this direction. Elastic like that. So this is a final velocity, and the direction is this one. So what is the horizontal component? This will be V cos of theta. The vertical component, this will be V sine of theta. So now, what you do here is that now the horizontal we should be having M1 U1 is equal to M1 plus M2 times V cos. Then vertically we shall have M2 U2 is equal to, now vertically we shall have M1 plus M2 times what? V sine of what? V sine of theta. So under vertical motion there is initial momentum, and under horizontal motion there is initial momentum. So let us go and look at the solid friction. So solid friction, we shall say this is the force that opposes relative motion between two surfaces in contact. Relative motion of two surfaces in contact. It can either be solid friction or fluid what? Friction. Then we go types of friction. Types of friction. Number 1, static. Static friction is the force that opposes motion between two surfaces that are about to slide over each other. That are about to slide over each other. Then we say, under static we say, limiting frictional force. Limiting frictional force is the maximum frictional force. Maximum frictional force between two surfaces in contact when relative motion is just static. Number 2, kinetic or sliding or dynamic is the frictional force that exists between two surfaces that are in motion. Between two surfaces which are already in motion. Then laws of friction. Laws of friction. Okay? So we can look at laws of what? Of friction. So what are the laws of friction? Number 1. Number 1, laws of friction. So we have the laws. They are there. Laws of solid friction. Frictional force opposes relative motion between two surfaces in contact. opposes. Then frictional force is independent of the area of contact provided the normal reaction is constant. Or we can say that frictional force is independent of the area of contact, but depends on the nature of the surfaces. But depends on the nature of the what? The surfaces. Then here we have limiting frictional force is directly proportional to the normal reaction, but independent of relative velocities of the surfaces. So let us look at the molecular theory to explain the laws. The molecular theory to explain the what? So we have molecular theory to explain the laws of friction. So the first one was saying that the frictional force opposes the relative motion between two surfaces in contact. So when two surfaces are put in contact, they rest on each other's small projections. Because the surfaces are not smooth, they are rough. That means that they are very tiny projections where the surfaces rest on each other. Now, because they rest on small projections, then we expect that the area is very small. Since the area is very small, the pressure at the projections is very high. That leads to the projection is getting welded. So when they are welded, they interlock each other. Before the motion can take place, these weldings must be broken before the motion can take place. Therefore, the force that opposes the motion comes in. Then the other was saying that it is independent on the area. So the actual area of contact is the sum of the tiny projections that adhere to each other, which is independent of what? Surface area. Hence, ρ2. Now, the other one is the normal reaction. Frictional force is direct proportional to the normal reaction. So, increasing the weight increases the pressure at the welds, hence, a very greater limiting frictional force. Because you see, when the weight is increased, okay, the pressure at the points of projections will increase, which means that the pressure at the welds will increase. So, meaning that before the welds the motion can take place, a very big force is required to break the what? The welds. Hence, frictional force. Is that okay? Yeah. So, those are the molecular laws explaining the laws of solid friction. So, we can go and look at coefficient of friction. Coefficient of what? Friction. Coefficient of what? Of friction. Coefficient of friction. So supposing, let me say, this is rough. I say, now this block of wood has normal reaction R and has what? Has the mg, the weight down here, and suppose this is a pulling what? The pulling force. Here there is no what? There is frictional force. So that we shall say that our frictional force is equal to mu r. Okay? Where r is equal to m what? Mg. Okay? So our coefficient of friction will now become F over R. Is the ratio of frictional force to the normal reaction. Then we got a measurement of coefficient of static friction. Of static friction. So we have method 1. There are two methods. So method 1. Method 1. There are two methods. Let us look at method. So we have the measurement of coefficient of static friction. Now method 1. We are saying that this is our horizontal surface A. This is a horizontal surface or a plane surface. So a block of wood is placed on horizontal surface like this, And then we're saying that one end of the surface, one end of the plane surface is tilted gently until the block just begins to move, until the block just slides down. So the angle of tilt, this angle here to the horizontal, that angle is measured using a protractor and is recorded. The experiment is repeated for like 3 times, and average value of theta is calculated, and the coefficient of static friction is gotten from that. Now, supposing it is NB, the static friction. So here we have frictional force. Here, this is a frictional force. Here we have normal reaction. Here we have mg. Here we have mg cos what? Cos of theta. Here we have mg sin theta. For static friction, F is equal to mg sin theta, where m is mass of the block. So experiment now. When I said this was an experiment to determine, the static friction. Experiment to determine static friction. We don't need this one here. From here you continue, okay? And after that you come here and say that the frictional force is gotten from mg sin what? Theta, where theta is the angle you have just measured using a protractor. M is mass of the block, so you have to say that the block is weight and its mass m is noted. G is acceleration due to gravity. So like that. So I go to method 2. Method 2 using what? Let's go to method what? Method 2. Method 2. Okay, method 2. Method 2, we have a block of wood of known mass m is placed on a horizontal table and is connected to a scale pad using a string passing over a smooth plane. Masses are added, known masses are added onto the scale pad one by one or in bits or one at a time until the block just moves. The total mass of the scale pad is noted. The coefficient is gotten from this. Since coefficient of static friction is frictional force over normal reaction, but frictional force is tension. Because frictional force is here, which is overcome by tension. So here there is what? There is a tension. But the tension is same as the weight of the scale pan. So that means that remember this is mg, mass of the scale pan. Okay? mg divided by mass of the wood, mass of the scale pan, mass of the wood, g. So it is mass of scale pan over mass of the wood. That's where you get it from. Now, supposing they are asking us that describe an experiment to determine the static friction. But do you go all those steps? No. We need this step. So we shall now say any B to determine static friction F, the weight of a scale pad is noted, and this is static frictional. So you go through the same procedures, but then for the case of this, the same procedures. Or you can even say, okay, yeah, actually here you just go through the same procedures. Yeah, but then for the case of coefficient, we can repeat the experiment using other blocks. This is when you have one block. If you have very many blocks, it means that you are going to plot a graph. You understand? So plotting a graph, you plot a graph of for many blocks. experiment is repeated using other wooden blocks of known masses M, and corresponding mass of scale pan noted. Next, results are tabulated A graph of M prime against M. A graph of M prime against M is plotted, and the slope gives us what? And the slope gives the coefficient of static friction. The slope gives the coefficient of static friction. So you have to take note of that. That is for the case of many blocks. If it is one block, you don't repeat the experiment. If there are many blocks, you repeat what? The experiment. Is that okay? So let us go to measurement of kinetic friction. Measurement of coefficient of kinetic friction. So we have this measurement of coefficient of kinetic friction. Then I say that the block of wood is weight and its mass M is noted. It is placed on a horizontal surface connected to a scale pan using a string passing over a smooth plane. Known masses are added onto scale pan one by one or one at a time or in bits. Each time giving the block a small push until the block continues to move with a uniform speed. The total mass of the scale pan is noted, and the coefficient is gotten from that. So that's one. Supposing they say that measurement of kinetic friction only, of kinetic friction. Maybe we can say, can be here? Not to say. You know what to say? For many blocks, for more than one block, the experiment is repeated. The experiment is repeated using different wooden blocks of known masses. And the corresponding mass of the scale pan M prime noted. Next, the results are tabulated. A graph of M prime mass of scale pan against M is plotted. A graph of M prime against M is plotted, and the slope S is calculated, and the slope gives the coefficient of the slope gives the coefficient of kinetic friction. Then let us check. Suppose the question says measurement of kinetic friction, only that. So what do we do in this case? This is what we do. So we have this measurement of kinetic friction. So we are going through the same steps. The only thing changes is here. The total weight of the scale pan is noted as W. And this is kinetic friction, because kinetic friction is a frictional force. So you cannot compare frictional force with the mass. It must be the weight of the scale pan. So here we don't get the frictional force is here. The kinetic frictional force is that one. So this is the tension T. But here there is what? There is weight of the scale pan, which is same as this tension. I think that. So when you measure, the tension is the weight of scale pan, but the tension is same as the kinetic frictional force. So here when I do this, you can pause. You can always pause and write, and then you move on like that. Then let us look at examples. Examples, not so. So this is the first example. A block of mass 3 kg slides down the plane which is inclined. So we have a plane. It is inclined at an angle of 30 degrees. So this one here, there is the normal reaction, and then there's its weight. The normal reaction is R. This is mg. This will be mg cos of theta, cos of 30. Then here we have another resolved component, which we already saw as mg sine of the angle. Now, if it is sliding down, if the motion is downward with acceleration A, the question is, where is the force that opposes motion? The force that will oppose the motion will be the force in that direction. And I've given us the force as 9 Newton. Now, if it is sliding down, of the two forces, which are better than the other? So automatically we shall now say that the resultant force F will become, that is mg sine of 30 minus 9. So but this is same as MA. So our MA will become mg sine 30 minus 9. So that means our mass is 3 is equal to 3. This is 3A is equal to 3 times 9.81 sine of 30 minus 9. So our A will become what? What will be our acceleration? Our acceleration is going to become 1.9 meters per second squared. So they are saying that find the distance moved in 5 seconds. So we can say S using S is equal to UT plus a half AT squared. So S will become 0 times 5 seconds plus, because it was initially at rest, a half times 1.989 times 5 squared. So what will be our distance moved? The distance moved will become 23.75 meters. Okay, so that's the distance covered. So we have this. They are saying that I think it's saying properly, yeah, that a body of mass 2 kilograms is moved up an incline by a pulling force. So we have, let me say, this is the incline. This is the horizontal. The angle is 40 what? 45. So it is moved up by the pulling force B. So the frictional force is down. And then here we have mg, okay, cos of 45. Then here we have mg, normal reaction here. Then here we shall have mg sine of 45. Okay, 45 here, like that. So now we are saying that if it is proved up, so the acceleration is what? It is up. So what is the resultant force? The resultant force will be F is equal to P minus, because this one is greater than the other forces, so these ones are in the same direction, so you add them, that's the frictional force, plus C, plus mg sine 45. But our frictional force is same as mu R, which will become mu mg cos of 45. Okay, so I think we can substitute. What do we get when we substitute? When we substitute, you get your answer as, let me see, you get your answer as 0. Okay, so our F, but F is in MA, so this is MA, the same as P minus, this is mu mg cos of 45 plus mg sine of 45. So that means our P will become MA plus mu mg cos of 45 plus mg sine of 45. So the mass, calculate out the mass. The mass is 2. Acceleration is 1.5 plus 0.3 times 9.81 cos 45 plus 9.81 sin 45, because M is already out. So our pulling force will now become 21 what? 21. So from there we can now put the exercise that you can do after going through this work. So this is exercise. You have this. So when they say the particle, they have given us the weight of the particle. So from the weight of the particle, you can get the mass of the particle, because weight is equal to mg. Okay, weight is equal to mg. So you can get the mass from weight equals mg. So they have given us the angle of inclination as tan over. So use a calculator to get the tan inverse and get this angle. Now it is at a point of moving up, so meaning that this horizontal force is acting upward. So if it acts upward, there are forces which are opposite direction. So you have to get the resultant force, and after that you can be able to get acceleration, I think, and etc. Now here this is a track. So this is a track colliding with another track. So when they collide, of course, you use after collision they stick together, and then they skid together before they stop. You know, when they collide, obviously they come to what? To stop. Yeah. So before they come to stop, they skid, and when they skid is sliding. When they skid, the road is not what? Smooth. So it is a rough one. So that means that you have to use momentum to get the final velocity, the common velocity. After getting the common velocity, that will be the initial velocity for which they are skidding. That will be initial velocity when the two bodies start what? Skidding. The final velocity after skidding will be 0. So that will be deceleration. So the acceleration we get will be a deceleration, negative. But of course, you know that frictional force is the same as mu r, which is same as m. So using this one, we'll be able to get the acceleration. But you know my acceleration, so when you substitute, it is mu mg equals ma. So this will cancel. So acceleration is equal to mu what? Acceleration is equal to mu g. Is that clear? Then where we had this angle theta, and we know that we have a block here. Yeah. So because we said that coefficient of static friction is equal to frictional force over normal reaction.